Hello everybody. In this session we're going to look at properties of limits. Now if we consider the basic algebraic operations we can do with numbers like adding, subtracting, multiplying, dividing, and exponentiating, if we consider that as a group, those properties commute with operation of limits. What do I mean by that is if you have, say, you want to take the limit of a function which has some of these properties in it. So what you could do is you could take the limit first and then evaluate those operations or perform those operations, or you could do the other way around. You could perform those operations first and then take the limits. Here we're showing three cases. First we have the sum of two functions, then we have the difference, and then we have the product. And in each case we're taking the limit of those functions when x goes to some number a. So we could either perform the algebra inside them, or you could do the other way around. You could find the limits of each one of those quantities first, and then do the operation of addition, subtraction, or multiplication. It works equally well, even if there is division, but you have to be careful about that when you are going to be evaluating the limit, or when you're going to be in the algebra, that the function gx, which happens to be in the denominator, exists. And finally, the same can be said about exponentiating. Limit of a function fx to the power of gx, limit of that when x goes to some number a is exactly the same as if we found the limit of fx, first limit of gx also, and then find the power of those. Let's take a look at this simple example in which we have limit of x over x minus 2 over x minus 2. When x goes to 2, and I said, let's say x approaches 2 from the positive sides, from higher than 2 values. So let's first of all find the limit, and then do the algebra. So we're going to do the limit first and algebra last. Here we rewrite the expression, limit of each one of the terms first. And if we find the limiting value of the first term, it is 2 plus, which means 2 is approaching from values higher than 2, divided by 2 plus minus 2, minus 2 over 2 plus minus 2. At this point, we have gotten rid of the limits, so we are free to do the algebra, and so it comes exactly equal to 1. Now let's take a look at this example when we do the algebra first and take the limits last. We have the same problem here. In here, we are not taking the limit yet, but we are doing the algebra inside here first. So we're combining these terms. X minus 2 divided by x minus 2, they have the same denominator. And the algebra inside reveals that this is just 1, and limiting value of a constant is always whatever that constant is. So it's exactly, here we have it. Taking limit of a function that involves operations of addition, multiplication, division, or exponentiation in it, taking limits commutes with those operations. You can either take the limits first and then perform the operations, or you can perform the operations first and then take the limits. Now the important question is, why don't we just simply take the limits first? Well, sometimes limits of some functions will not exist if we don't do the operations. What the operations do, especially in the case of division by 0 or having a negative number under a square root, the operations, the algebra actually kind of hides those problems and allows us to compute a limit. But otherwise, the operations are, these operations commute with the operation of taking limits.